So what I'm going to talk about here is something called significant figures. And significant figures is going to be exceedingly important to you. Let me try to write this. Significant. Looking on my handwriting. Figures. This is going to be a subject that pretty much every science class you're ever going to take from now on is going to start talking about. First couple days. So hopefully after last video, you got this idea that whenever you're going to make a measurement, you always make a measurement to one level of uncertainty, which means you look at the instrument, you figure out how many known decimal places there are, and then you go to one more guess. And that last guess then tells the reader what kind of instrument was being used. Well, what I'm going to do this time is, I'm not sure what, I'm going to show you something else along those same lines. Say I have this box, and what I want to do is I'm going to measure the surface area of this box. And I'm going to have two rulers. They're going to be the same ruler, and they're going to be divided like this. Okay, so I'm sitting there trying to figure out the surface area of this box. So according to what I did in the last video, I'm looking at this ruler, and let's say these are centimeters in both of them. Okay, and I look at the ruler and I say, okay, I'm certain that it's 1 centimeter, 2 centimeters, 3 centimeters, 4 centimeters, 5 centimeters, and now I'm going to make a guess. Well, if I look how that comes down, I'm going to make that guess somewhere right about there. I'm going to call the measurement of this 5 point, and I'm looking at that going, it's not a half, and it's about, I'm going to call it 5.3 centimeters. And I'm going to do the same thing on this dimension going up, right? So I got 1, 2, 3, 4, 5 again. And this time I kind of look across, oops, that's too high. But anyway, go down there a little bit. Look across there, doesn't really matter. But I'm going to call that measurement 5.7 centimeters. That last digit, this one right there, in both of those cases is uncertain, but it's important because it tells me what sort of ruler, what sort of instrument I used to make the measurement. Now, what I'm going to do is I'm going to multiply these two numbers together to find the surface area. So I'm going to take 5.3 centimeters and I'm going to multiply it by 5.7 centimeters. When I do that, okay, take the calculator, 5.3 divided by 5.7, I end up with, no, multiplied, 5.3 times 5.7, I end up with 30.21 centimeters squared. Now, here comes the deal. When I see that number, 30.21, that implies that that was a pretty good measurement. I was able to make a measurement to 2/10, 1/100, whatever, but that is really just a measurement that is derived from my calculator. It's the math. It's not the measurement that came from the rulers that I used. The rulers that I used only gave me two number values. So, okay, so this is what I got to do. I can't let my calculator give me a more precise number than I had originally. So what I do is I look at this and say, okay, I had two significant, and this is where the part of significant figures comes in. I have two significant digits here, and I have two significant digits there. My answer must have two significant digits. So starting at the very first digit, the 3 is significant, the 0 is significant, so I round this number back to 30 centimeters squared, and that is the proper answer. Because that number, 30, represents the surface area of this square using rulers that were of this precision, had 1 centimeter calibration marks in it, and didn't imply any greater precision than I had originally. So let me try it. Oops, let me roll this up. How do I roll it up? I forget. No. Oh well, I'm going to erase everything because I want to keep talking about this. So give me a second to erase everything. So how do you know if you have a significant figure? Or you need to worry about this. You guys need to worry about significant figures in every single calculation that you are ever going to make in this class. The vast majority of the numbers that we use in this class come from a measurement. They're going to have units attached to them. They're going to represent centimeters, grams, millimeters, something called a mole, which we'll get to a little bit later. But every number that we have always has a unit attached to it, which means that it comes from a measurement that was being made somewhere along the line. So I'm going to give you some numbers, and I'm going to talk about the counting of the significant figures. If you have whole numbers, like 42, there are two, I'm not sure what's going on. Since I erased it, things got kind of messed up. Let's try this again. Go with the blue one. Okay. Make my little doodad. So, if I have a number 42, that number, those are all whole numbers, there would be two significant figs in that number. If I have this number, 402, because the 0 is surrounded by whole numbers, that would have 3 sig figs. If I have this number, 0.002, these zeros are said to be uncertain. And I could show you in class why that is maybe a little later. It has to do with the units, but the only significant figure in this value, 0.002, is the last two. So there is 1 sig fig in that number. Now if I go this way, let's go 2.000, all of the zeros to the right of the decimal place are significant. So here I'm going to have 4 sig figs. Now you can kind of start seeing what's going on, because in order to get this number right here, 2.000, that implies a fairly accurate or precise instrument. That would be a pretty expensive number to come up with, and it has 4 sig figs. So the only place that things get a little tricky, and I'll show you what goes with the trick, is when you have a number that doesn't have decimal places. For example, this number, 420. Now this 0 right here, it's to the right of the last whole number. But because there is no decimal place, it is not significant. The only significant digits are the 4, this one, and the 2. So that has 2 sig figs. And we'll practice this in class an awful lot.